project is the autonomous lawnmower with advisors Dr. Izadi and Dr. Nelson.
This project was undertaken because new innovative technology in the robotic mowing field is an upcoming market. There are numerous autonomous lawnmowers on the market today that use guide wires to sense the outer edges of the lawn. This is done by bouncing off the signals given off by the wires that are either buried underneath the lawn or staked into the lawn. This creates irregular mowing patterns. This is not only very expensive to install, but prone to durability flaws, as both above ground and below ground wires require a lot of maintenance. The main goal was to create a fully autonomous lawnmower that instead of wires uses GPS location to map the perimeter of a lawn and stay within the confines of that lawn, thus eliminating the need for external wires.
In order to achieve our goals for this project, a PVC frame was built as the robot's chassis because it is lightweight and easily customizable. Two 12-volt DC motors were used to power the movement. As Katie mentioned before, a GPS mapping algorithm was developed to move the robot around the lawn. This was done by checking its current position against the coordinate positions for the perimeter as it traversed the lawn. While mowing the lawn, various sensors are used to detect objects and animals that may come into contact with the robot. Infrared sensors are used to detect humans and animals, and a distance sensor and video camera can take pictures of objects it runs into as it mows the lawn.
If I jump in front, they stop. The robot is equipped with infrared sensors on each side, which will be able to detect if a person comes within about 5 feet. If this is the case, an interrupt service routine is triggered, which stops movement and shuts down the blade. An ultrasonic sensor is also used to detect inanimate objects, such as a wall, so the robot does not crash. They will stop around 2 minutes before contact would be made.
Some engineering principles used was from mechanics and materials. Failure theories were solved for to determine if the blade motor could withstand the torsional force due to the rotating blade. Principal stresses and max shear stress felt on the motor shaft were found and compared to the yield stress of the material. All three factors of safety were well over 1, which declared that the blade motor was able to withstand the force of the rotating blade. This meant there was no concern of failure at the shaft. The prototype was lightweight cardboard with a 1 mm shaft, and it was deemed to be too weak, so a new 3 mm shaft motor with a gearbox was purchased. The final design was created out of PVC piping since they are lightweight and allowed various design options. A 6 mm shaft with 550 RPM motor was purchased since it produces enough RPMs and torque. The size had to be reduced for less weight and stress on the motors. A blade height changing mechanism was implemented for options for the user.
The main hardware features include a Raspberry Pi and a motor controller. The hardware diagram seen is a summary of all the connections on the robot.
Our software features an algorithm that uses GPS values to set an optimal path around your lawn. The algorithm specifically uses the GPS value at turning points to calculate distance and angle between corners. From there, an initial path is calculated, using one side length as a starting off point. Infrared and distance sensors locate obstructions, causing the mower to move around the object before returning to its set path.
Moving forward, there are a few things we'd like to do to improve the robot's design. First, we would install shielding around the blade so that rocks and sticks kicked up won't get sent flying all over the place. Next, we would 3D print housings for the camera and infrared sensor so that they're safe and stable during the robot's operation. Lastly, to make this a truly autonomous unit, we like it to return to a home base where it would charge in between runs. The charging can be implemented through contact charging or inductive charging units stored in the roof of the base. An automatic door can even be installed using RFID communication to protect the robot further from the elements and animals.
In the future, we want to expand on our existing algorithm to more precisely mow your lawn. To do this, we would add a GPS grid system as well as software improvements to handle gradual turns. These features will ensure the entire lawn gets mowed, as well as making a more efficient path.
One issue we ran into when designing was the battery's weight and lower power. In the future, a more powerful, possibly lighter battery could be used. The voltage could be then stepped down using a buck converter to power the pi and the motors together. A basic voltage converter circuit with a USB port could be used. Thank you.